Alright, in this example with the law of cosines, we're going to try to solve the triangle ABC with three pieces of information given. An angle and two sides. In fact, it's an angle, it's two sides and the included angle. Okay, so angle B is 47 degrees, angle A is 21 feet, and angle C is 17 feet. So I could draw a sketch of this, don't have to, but I could. And I'm not sure exactly what it's going to look like, but I could get something like a 47-degree angle in there. Just a little over a 45-degree angle. And let's say one of the sides here, A, is 21 feet, and the other side is 17, so that one's going to be a little shorter. And so it's not necessarily clear whether this is going to come back as an obtuse angle or an acute angle or a right angle. I'm not sure. I'm going to draw it in as an obtuse, but I guess it doesn't really matter. Okay, and so if that's side A, then angle A is here, angle C is here, and little b is there. So we still have three things to find. We have to find little b, big A, big C, right? So when we do this, starting with these three pieces of information, I don't have enough to use the law of sines, right? The law of sines, remember, requires that you have one full ratio known. So you have to know a side and its opposite angle. It could be A, B, or C. It doesn't matter. But here, I don't have that scenario. I have an angle, but not its opposite side. I have a side here, but not its opposite angle. And I have a side here, but not its opposite angle. So I don't have that combination that I would need to use the law of sines. So the law of cosines is necessary because the law of cosines doesn't require that. Instead, what I'm going to do is I'm going to use the law of cosines that has an angle B because that's the angle I know. The corresponding law of cosines, if you know the angle B, that means it starts with the side B by itself, so B squared, equals A squared plus C squared minus 2AC times the cosine of that angle B, right? So the law of cosines, like I said, will have whatever angle you're given, start with that on the other side as your side, the opposite side. And then your A and the C, which are the ones that are given, are going to go on the same side as the side B, as the angle B, as the angle B, all right? Okay, so then I just plug stuff in. So I get B squared equals, well, A is 21, so 21 squared. C is 17, so 17 squared. Minus 2 times 21 times 17 times the cosine of 47 degrees. Well, I plug all that stuff into my calculator and I'm going to get a number. And of course, we're going to be rounding these off. I'm not going to ask for exact values on the cosine of 47. So there's going to be some rounding involved in these. But I think the best thing to do is to round as far down the line as possible. So I'm going to go ahead and type all this stuff in one shot. 21 squared plus 17 squared minus 2 times 21 times 17 times the cosine of 47. I better make sure I'm in degree mode, which I am. And I hit enter. And I get 243. So B squared is approximately 243. It's a weird mark on my whiteboard there. It looks like a decimal, but it's not. I better move that. 243.053 ... Anyway, it's basically 243. When I take the square root of that answer to solve for B, we're going to get about 15.6. Okay, so B is approximately 15.59, but actually I'm going to go ahead, because everything is rounded to the nearest whole number in my original numbers, I'm going to round that off to 16. So B is approximately 16 feet. Okay, so that's the missing side is now known. So now I need to find the two missing angles A and C. Well, we have a slight problem there. If I use the law of sines, for instance, I could actually use the law of sines now because I have both side B and angle B. So I have enough for one of the ratios. The problem is when you use the inverse sine at the end of that to solve, the inverse sine gives you angles in the fourth and first quadrants. The problem is I don't know if these angles are going to be first or second quadrant angles. They could be acute or obtuse. I'm not really sure. And so the inverse sine leaves some ambiguity there. It can't give us a second quadrant angle if that's what the angle really is. And so we don't know. If it gives us a first quadrant angle, we don't know if we need to then convert it to a second quadrant angle or leave it as a first quadrant angle. And so the law of sines is going to be a little bit ambiguous still. So instead, we're going to use the law of cosines a second time. And it's best to use it with I believe it's the smallest angle. Yeah, the smaller of the two remaining angles. And you might say, well, how do I know which one's the smaller angle? I don't know what either one of them are. Well, yes, you know how they are relative to each other based upon their opposite sides. So if B is approximately 16 feet, this is A down here, or no, this is C, and this is A. So if B is approximately 16 feet, but it's not B in question, it's A and C, I'm sorry. A is 21, C is 17. The angle opposite the smaller side is going to be a smaller angle, so C is definitely the smaller one. So we're going to start with the smaller one. The smaller one has to be acute. It can't be obtuse, right? Because if the smaller one were obtuse, the bigger one would then also have to be obtuse. If that makes sense, right? If you have a smaller angle that's obtuse than the bigger angle, well, what's bigger than an obtuse angle? It's still an obtuse angle, right? If an angle is over 90 degrees and then another angle is bigger than that, they're both over 90 degrees. Well, you can't have two obtuse angles on a triangle. So you've guaranteed that the smaller of the two is going to be acute, a first quadrant angle, right? Acute and first quadrant go together, obtuse and second quadrant go together. Hopefully you've picked up on that by now. So you go with the smaller of the two angles because you know that and actually you can use the law of sines. I think I said law of cosines a moment ago. You can actually use the law of sines now with the smaller angle because we know that it's got to be acute. If it's obtuse, we'll end up with two obtuse angles on the same triangle, and that just doesn't work. You can't have that. Right? The angle sum formula you would surpass 180 degrees for everything. So we're going to go to the smaller angle. So find smaller angle first, which in our case is going to be angle C. We know that based upon the lengths of the opposite sides. Okay, so if I know that, then I can set up the law of sines using the known information for big B and little b, and little c, and the unknown value for big C is what we're going to solve for. So we have little b over the sine of big B equals little c over the sine of big C, and then I just plug in what's needed here. So little b is, and then instead of using 16, I want to limit my rounding error, so I'm actually going to go back to the 15.59. That's a little bit better. It's still rounded, but it's a little bit better. So we'll go 15.59 over the sine of big B. Where's big B? 47. Equals little c, which is 17, over the sine of big C, which we don't know. Now it's a proportion. I'm going to cross multiply. So I'm going to get 15 15.59 times the sine of c equals 17 times the sine of 47 degrees. If I divide by the 15.59 and then use the inverse sine, we'll find angle C. So I'm going to write that all in one step. So angle C is found using the inverse sine. So I divide out the 15.5 and then use the inverse sine. So it's going to be 17 times the sine of 47 all over 15.59. Right, so it's this expression divided by 15.59, and then I apply the inverse sine to it. Now remember, the inverse sine is going to give me either a first quadrant angle or a fourth quadrant angle. I know that angle C is going to be acute, so I know it's going to be a first quadrant angle. Okay, so I can always translate it in my calculator. There it is. So I'm going to use inverse sine of 17 times the sine of 47 degrees divided by 15.59, close parenthesis, 52.9 roughly. So this is approximately a 52 point, I think it was 89 degrees. Yeah, so again, everything's rounded to the nearest whole number, so I'm going to go ahead and stick with that to be consistent. So we're going to say C is approximately, what's that, 53 degrees. Okay. Well, now that allows us to find the third angle using the angle sum formula. I have 47 degree angle, a 53 degree angle. I add those up and subtract them from 180 to find the missing side. So 53 and 47 is 100 degrees. Okay, so angle A is going to be 180 minus that 100 degrees, which is approximately an 80 degree angle. Okay, so it turns out, I drew this a little bit off, it turns out that this angle A is not an obtuse angle like I thought it might be. It's actually an acute angle, but it's pretty close to 90 degrees, right, 80 degree angle. So it's fairly steep right there. I just have it drawn in a slightly different direction than it really should be. Okay, and that's okay. It's not that big of a deal. Just wanted to verify or to point out that that's the case. Now, it's always a good idea at the end to make sure you didn't miss something with that law of sines. Again, remember the sine, when you use the inverse sine, you don't always get the angle that you're looking for. Sometimes you need a second quadrant angle. And to make sure that you didn't make a mistake there, because had you solved for angle A first, you could have wound up with an 80 degree angle or a 110 degree angle, maybe not being sure whether it's obtuse or acute. And so just to make sure everything works out well, I'm going to make sure all my my angles are relative to each other correctly, based upon the side. So B is the smallest side, A is the largest side. B is the smallest angle, A is the largest angle. That works. There's other, I don't know. Maybe that's not the best way to check, because you could have still made a mistake in that, and they still work out relative to each other. But it's a nice check anyway, just to make sure you didn't make any major mistakes, or at least it reduces some things. So if you see that it doesn't work out that way, that your biggest side is not opposite your biggest angle or something like that, then you know you did something wrong. So at least it's a little bit of a check. Okay, so I always go through and just kind of mentally make sure that works out. All right, so that's a good one. Next example will show you where instead of having an angle included between the two sides, we'll do 3 sides. We'll go with 3 sides and then find the angles.